The work function for a metal surface is 4.14 electron volt. The threshold wavelength for this metal surface is 4125 angstrom, 2062.5 angstrom, 3000 angstrom, and 6000 angstrom. These four options are given. But before that, let us try to understand that what is work function, okay, what is threshold wavelength, okay, for a metal surface. So it is basically a question of Einstein's photoelectric equation. Let us consider it is a metal surface, and according to Einstein's, if a light of single frequency or a monochromatic light is just incident on that surface, and the light having the frequency nu or the wavelength lambda, then each of the photon of this incident light basically contain the energy E equal to h nu or hc divided by lambda. Now when this energy of photon is incident on it, the metallic electrons inside the metal can do two things, okay, or two things is observed in the experiment. Either this photon is completely reflected or it is completely absorbed by the metallic electron. Two things can happen. Now if it is absorbed, the energy h nu is used up in two ways. Okay, a portion of energy is used to come out from this metallic surface, which is called the work function, and rest of the energy will be the part of the or remain within that electron which is just comes out. Okay, and this W naught plus 1 by 2 m v max square, this can be also written. Okay, this can be also written max square. Now this is called the work function W naught, and the threshold wavelength. Threshold wavelength is a particular wavelength. If the wavelength of the radiation is below this, then we will not see any kind of photoelectric emission. If the frequency of the incident radiation is below a particular characteristic frequency, which is called the threshold frequency. Threshold means from that value of frequency, the photoelectric emission occurs. Okay, and if an electron having the frequency nu naught, then its energy is h nu. Okay, now capital E equal to h nu naught equal to hc divided by lambda naught. Lambda is called the threshold frequency, sorry, threshold wavelength. The energy which is given here, it is 4.14 electron volt. 4.14 electron volt. If you want to convert this thing in the joule, then it will be 4.14 multiplied by the charge of the electron, 1.6 into 10 to the power minus 19 joule. What is h? H is nothing but the Planck's constant, that is 6.626 into 10 to the power minus of 34 joule. C is the velocity of light in vacuum, that is 3 into 10 to the power 8 meter per second. So let us put all the values here such that we can find it out what is the threshold wavelength. So lambda naught equal to nothing but hc divided by capital E. Okay. So 6.626 into 10 to the power minus 34 joules second it is. So let us put the value 6.626 multiplied by 10 to the power minus 34. C is 3 into 10 to the power 8. Just putting the value. The value of the E is 4.14 multiplied by 1.6 into 10 to the power minus 19. Now we need to do the approximations little bit such that we can get the value. 6.626 can be written as 6.6, okay, 6.6, and it is 3. Okay, the powers I can write it down as minus 34 plus of 8. This minus 19 which is there, if I take it off, then it will be plus 19, and it is divided by 4.1 multiplied by 1.6. Okay, so let us do the cancellation. So it is 0.8, or rather say simply 8, and if it is 33, okay, sorry, 3.3, then if these all decimal places can be cut it out, it will be 33 and it will be simply 8. Now 33 can be written as 11, and if I just cut it out, that's but the approximation. Okay, before the approximation I just try to multiply this thing. It is nothing but 99 approximately 100, and this is 4.1 into 8, that is 328, 32.8, or approximately 33. So it is approximately is of the order of 3, or we can say 33. So it is greater than 3. So which values are represented here? Obviously it is approximately 3 or 3000 angstrom. So this type of approximations you need to do if you want to find it out the answer. Okay, it should not be around 2, because 33 divided by 32.8, it should be greater than 3 approx. Okay, so this type of approximations you need to do, and here I am not concerning about the power of 10. Whatever we will going to calculate, okay, that will be of the order of the angstrom, so we need not to think it about. So these approximations are allowed actually when the MCQ options are given. So the answer is 3000 angstrom. The work function of the metal surface is 4.14. The threshold frequency, threshold wavelength, which is required for emitting the radiations from the metal surface, it is 3000 angstrom. Thank you all.